Hello, everyone, and welcome to a new episode of the Tech Cafe podcast, streaming live on LinkedIn and YouTube. My name is Ahmed Misbah, and I'll be your host for today. Please allow me to welcome back our renowned guest speaker, Paige Watson, who'll talk to us today about taming legacy code with TDD and Strangler Pattern. Glad to have you again with us, Paige.
Oh, thank you. It's really exciting to be back.
Paige is a technical coach and consultant with over 25 years of experience. He's an internationally known technical coach who speaks and teaches worldwide. He understands the need for quality software as craft practices and has been able to help dozens of teams create well-crafted software and processes for maturing into high-performing scaling teams. This is Paige's third session with Tech Cafe. He previously delivered sessions on fluid scaling technology, fast, and extreme programming. I highly recommend you watch these great sessions on YouTube. Before we start, please allow me to introduce Tech Cafe. The Tech Cafe podcast first aired in March 2023. We started the podcast with the aim of empowering the tech community and inspiring innovation in the tech industry. So far, we have aired 35 episodes. We have hosted many great speakers that presented many topics, including extreme programming, test-driven development, software architecture, artificial intelligence, and many more. Last year, we were community partner with Startups Without Borders and Impact. We also sponsored the DevOps Days Cairo event. Visit our website to learn more about Tech Cafe and to contact us if you're interested in any of our services. So without further ado, I leave the mic to Paige. Let's tame that legacy code.
Fabulous. Thank you. So I'm going to talk about legacy code and mainly using the Strangler pattern to evolve our code, to add to it, to make it better and continue to grow it. But first, let's talk a little about. Let me get there we go. Let's talk a little about legacy code. Michael Feathers describes legacy code as code that simple code, without tests. And a lot of times this is correct. A lot of the legacy code bases, we don't have a good, strong testing framework around it. It's working. It's in production. It's making us money and money for the company. So we know it works, but it doesn't necessarily have automated test framework or tests that run as we make changes. And so actually there was a little better example or description that I heard from Nicholas Carlo, who said, legacy code is valuable code that you're afraid to change. I like this a lot better because oftentimes that fear of change comes from that not knowing what's going to happen, not knowing if those tests are, or if the code's going to continue to function as we expect it to. So I'm going to talk a little about the Strangler pattern. I actually heard it called the Strangler pattern in the beginning, but it comes from these Australian trees. They're called Strangler figs. And what they do is they grow around other trees and they eventually kill and replace them. Right? And Martin Fowler saw these trees when he was in Australia and was realizing that this was a good name for a pattern he'd been working on to gradually replace this existing code with new code instead of totally rewriting. Some of the benefits of the Strangler pattern are that it's incremental. You can extract and create new functionality without having to do a total rewrite. You can choose little bits of the code to extract, pull out, and create the new code around. I'll kind of get into that, and we'll show you an example of that as we write some code. It's very controlled. We know exactly what we're going to change and when. There's zero downtime when I decide to implement this pattern and to upgrade my legacy code. I can write little bits and immediately push it out to our clients. There's no downtime of having to, rewrite this large code base. It allows me to continue to use the existing code until I'm ready to move forward. It's very low risk because of that. It's easy to roll back. It's easily testable, and it's very easy to release, whether you release it automatically applying the changes, or you release it with feature flags. I've seen a lot of people do that as well. You can release it to some of the audience. You can release it to all of the audience. It's totally up to you. And that's one of the real benefits, I think, of this over a rewrite is it's so, how do I say, modular. So when we apply the pattern, what we first need to do is we need to pin the current functionality. We know that our legacy code base works. It's been in production for years. It's making us money, like I said, but we don't want to make changes that are going to introduce a defect. So we're going to pin the functionality with pinning tests. Pinning tests are just that. They're tests, unlike TDD, where we write a test that fails and then we create a functionality to make that test pass. These tests pass right away. We know what the outcome is going to be, and they just pin the functionality so that as we refactor, we know that we're not introducing defects. So once we get those pinning tests in place, we separate and isolate the code that's going to be changed. We'll extract a method, or we'll create a new class, or we'll use dependency inversion. And then we'll implement those changes and remove the dead code, and then we'll continue to repeat that if needed. I talk a little about TDD, and just for knowledge, oftentimes I think of using TDD as writing a test that fails, making that test pass, refactoring the code, and then integrating it or committing it back into the code base, and repeating that pattern in very small increments. Often when I think of tests, I like to think of them as code as a requirement. So my tests that drive my functionality change actually mirror the functionality that I want, the requirement that I want, as opposed to the functionality that the code is doing. And I'll talk a little more about that as we get into it as well. So when we use TDD to add functionality to legacy code, it's very much like the Strangler pattern. Again, I'm going to isolate the change. I'm going to write unit tests to drive that change. And then I'm going to refactor as needed. So let's talk about what we're going to do today. I'm going to actually do some coding, which is never always goes the way I expect, but here's what I'm going to work on. I have a hand-rolled log to file class. Does just what you would expect it to. It takes and writes a log to a file locally. And I want to change that to use the highlight IO logging in the cloud. Oftentimes I've run into different places where I've worked, and we've moved from one type of logging library to another. And sometimes those changes are big. Sometimes they're very deep, in that we have a lot of work to do to change the way that we're writing to the logging and configuration and setup and all those sort of things. And so this is something that I've seen happen several times. I think it's a pretty good example. The code base that I'm using is fairly contrived. It's a code base that I use to sort of practice on quite a bit. And so I'm hoping you'll look at it and go, oh man, that's horrible looking, because it is, and that's okay. For today's practice, we'll be focusing on the logging, although there might be some other things that come out of it that we say like, oh, let's make this update. but don't worry too much about that part. So I was talking about our current log to file. This is what it does. It just logs to a local file in the directory, and I'll show you this. So as we start, what's the first thing I want to do to make this change? I want to isolate this. And how am I going to isolate it? I'm going to isolate it by adding an interface. I'm going to make some, these are some simple calls that I'm going to use for calling the highlight logger, and we'll take a look at that. And I'm just kind of have them in a Scratch file. I'm not going to actually use this file, but you'll see it. It's one that I'm using to kind of hold the code as I need it. So let's write some code. All right. So this is my my elevator class. It started out as a elevator kata. The whole idea being that you have an elevator and you give it some requests, either internally you push a button on the inside or you push a button on the outside, and it chooses which floor it's going to go to based on, you know, which direction it's heading, where it is in the building, what the next closest floor is, et cetera, et cetera. You'll notice that we have our logger here. We're calling it, we're starting a new log here. And we are logging, well, throughout here and there. You'll see several of these. Also, when we look at this, we'll notice that this has one test, right? It's not a very good test. It's not doesn't really do a whole lot. I'm going to run all the tests. That's how I'm going to show you that the code is working. Right now, you'll notice that it writes 3 logs. It writes one for the elevator class that we were looking at. It writes one for the interface class, which also has a logger here, right? And then we have this this joke for the ride service. Here we go. And it also has a logger. It's the whole idea here is that it's going to return a joke that will be displayed on the internal panel, again, contrived. But what we can do is we can choose to change the logger, and we're going to extract it from just one place. So this goes back to that sort of modular aspect of the Strangler pattern. I'm going to extract it, and I'm going to just change it in one place to start. And then later on, we can go ahead and continue to add and change to the other ones. In this case, I think we'll use the elevator class. And the first thing that I want to do is I want to write my pinning tests. This test is not so great. There's one test, and it doesn't really test the whole thing. You know, the name's terrible. I'm not exactly sure what it's doing. So let's go ahead and write those tests, and I actually have them ready. All right, so I'm going to write those tests. Let me get rid of those so that we know this is continuing to work. I've gone down and I've written pinning tests, and let's look at some of them. All right, so our pinning tests, I changed some of the names, made it a little more understandable, added tests around all the public functions that exist in the elevator. And this allows me to make sure that my code doesn't change as I do the refactor. Right? What you'll notice that we don't have here, we don't have any tests that actually test the logging. And there's oftentimes some, how do I say? There's some discussion around that. Do I want to test that I'm calling the logger, because I'm testing functionality. In this case, I don't think I need to for our example. I think sometimes you can, if you are sort of writing your own logging classes, you can test that the functionality works as you expect. You pass, say, you pass a, let's see if I have one down here. You pass your exception to the logger and it formats it correctly. That would be a test I would write. I'm not sure I would necessarily test that it writes, like within the elevator, that it writes that code that I expect it to write, the output. So, all right, let's go back. First thing we're going to do is we're going to run all of our tests. We see that we've got a few more tests here. Good. They're all running. We're going to look, here's our elevator class logger output. Each one of these is a test that runs. We also have output for the joke service and for the writer interface service. All right. So let's go back and start looking at the logging service. And I'm going to make this a little easier. So one of the first things that we talked about wanting to do here was to extract this as an interface so that we can sort of separate our usage. So luckily, there's a really nice, in IntelliJ, a really nice automated refactoring. I'm going to extract the interface here. And as I do, I'm going to call this interface, how about elevator? It's an elevator logger, sure. And I'm going to want the start, new log, the info, and the error. I don't necessarily want the write to output or get buffered writer. Those have to do with writing to a local file. But these three, the info, the error, and the start new log, are have to do with the actual usage of the class. So let's refactor that and see what we get. Okay, I'm going to choose no, and I'm going to add that just so I know. All right, and so now we have our elevator logger interface, and we have our log to file interface that implements these three public functions. So let's go look into our elevator. First thing I want to do again is I want to run my tests. And hope they all pass. They do. And actually, I'm going to delete my logs each time so that I can see that I'm still getting, things are getting written to the logs. There they are. So my elevator class, it's still writing to the logs. Great. My tests still pass. I have an interface. So the next thing I want to do is I want to start using the interface instead of the logging class. Again, we're sort of separating the concerns here. So I'm just going to come down and I'm going to do this, create that. Really, that's the only thing I need to do right here, right? Again, delete the tests, or delete the logs, sorry, run the tests, make sure all my tests pass. And my logs, I could be diffing these to make sure that they are the same. I'm not going to for this. And in fact, actually, there's a really good framework called Approvals, which I could be using, which would be really nice. Approvals is sort of a diff framework that will run in your tests and will sort of diff the output. And if the output is different, then it fails the test. Sort of like snapshot testing as well, but snapshot testing for for your backend classes instead of just your front end UI. Right. So let's talk about how to start adding this. First thing I'm going to do is I'm going to extract this. Let's close this up. I'm going to extract this. This here is a, I have code that I left in there. Okay. This here is an internal, or sorry, it's a dependency that I am creating internally. And actually, what I should do is I should create this pass this in as an elevator logger. And I can do this within my tests as well. So the nice thing about having an interface, let's open up our tests. The nice thing about having it as an interface is I can create a separate class. And I'm going to do that right here. Let's call it fake logger. New.var. So I have a fake logger here. And actually, I'm going to create it as an elevator. Okay, and keys. So I'm going to create this class. And this I care. Let's create it as an inner class here in the unit tests. In the elevator tests. Okay, so I have a fake logger that implements this elevator logger. We're going to implement those methods. Right now, we have the 3 methods here. I now have a fake logger. And now I can come up and I can start to pass this into my elevator. I'm going to go all the way up to the top. So I can actually pass fake logger here. And it's going to tell me that it doesn't match the required type. So let's split and move this to the right. Here's where it's asking me to pass that in. I'm going to change this type to the actual logger. I'm going to actually have to do that in a couple places. Oh. So now, what I've done here is that I have in my test passed in a fake logger. And what I want to do is I want to do this for all of my tests. So let's move this up here to the top of the unit tests. And let's come down and let's find all of these where I can pass that in. Ooh. Boy, hotkeys are hard. I know this is in several places, but I want to make sure that I'm able to sort of test my functionality without actually calling the live logger. And one of the ways I'll do that, you'll notice here that, let's just show you. If I come in here, I'll delete the logs again. If I run my tests, I'm still getting an elevator class logger here, right? It's definitely smaller. There's definitely only two
Paige, you've muted yourself, I think, by mistake.
Oh, thank you. Sorry. Where was I?
Yeah, so I think you need to repeat the last minute and a half, something like that.
Oh, shucks. I found that sometimes I accidentally touch my microphone and it mutes me. So I apologize.
No, it happens. No. So you just need to repeat the last like 1 minute or something. Okay.
Yeah. So what I was talking about was that I want to pass in this fake logger that I've created into all instances of the elevator class in my tests. Part of extracting that functionality is not using the actual log to file that exists, not using this default one. I don't want to use this functionality because it's going to change. What I want to do is I want to have this fake in my tests so that it doesn't matter whether I'm using the local logging to file or I'm using the logging to the cloud or whatever, right? I'm pulling that dependency out. I'm inverting it. So once I have done that, and I was showing you here that when I ran it a minute or two ago, I still had some elevator class constructors that were not taking this fake logger, and so it was actually still using this. So now if I run this, we should notice that the elevator class is not writing to the logs. Right, I'm not getting that logger. Well, and we're not. So we're only getting the joke for the ride and the rider interface class logging using the log to file class. And that's good. So I've separated out that functionality in my testing. Now let's continue on to separate that out and move more towards the logging using the cloud. So I have an interface, the elevator logger. I have the log to file. Let's create a new file, a new Java class. And what should we call this? How about it's the highlight logger, or better yet, log to highlight. That's okay. So I'm going to create this class, and I'm going to start out by implement that interface, and then I can implement those methods. Right. So now I have an elevator logger that will eventually be calling the log to highlight class. As I do that, I'm gonna again, going back to the reason we use this fake logger, it doesn't matter whether I log to the highlight or log to the file. At this point, the functionality of where it goes is not important. I also have the opportunity by creating this to add a little bit of testing here, and we will maybe we can do a little bit of that. Where are we at? Yeah, okay. I think I have a moment to do that. So I'm going to split and move that to the right. And let's see. I have a test that sorry. Yeah, no, you know what? I'm actually going to just continue on with doing this. We'll come back to maybe adding a little bit of the logging here, because I'm not 100% sure that I really want to test the functionality of the logger or test the functionality of the code. So instead, we're going to come back to the the log to highlight. Remember I said earlier that I had that code that showed me. Let's come in here, and I'm going to need to initialize it. I'm going to actually need to initialize it with the options. Probably the best way to do that is here. Oh, not there. In the constructor. Nope. Yeah, in the constructor. Sure, we'll do it there. Log to highlight. Now, obviously, what I'd really want to do is I want if I was using something with a dependency injection framework, I would do this someplace else. Maybe if I'm writing in Java, I'd create a bean and set it up here using these from a configuration file, et cetera, et cetera. For this case, I'm just going to initialize it here in the constructor, just for simplicity. And then we're going to come down here to starting a new log, and we can add function. We can add code there. We have our message. Say, what do we want to do? To say, we could say. Again, this is not the best code. I'm doing this quick and dirty like, but we can send an info log that we started a new log. Down here, we're actually going to do the same sort of thing. We're going to use the highlight functionality. And in this case, we're going to just use the message that they passed in. And then finally, we have our error functionality. I'm going to use that. And we're going to pass in our error. Right? So now I should have a log to highlight functionality that is fully matching the implementation in our event, in our elevator logger. And then I can come into our elevator Java file. And really the place that I need to do to make the change is right here. This is our public constructor. It's the very root sort of default constructor. It's going to chain all the way down, and it's going to create a new log to file. But I don't want log to file here. All I want is a new log to highlight. And let's see if, let's see, I was going to show, sorry. Oh, just a second here. I'm going to come back and see if I can't show you the file. I am missing where to go. There we go. Okay, let's pull up this. Here's the highlight app. You'll notice that there are no logs at this point. Let's see if we now get some logs in there. So let's go back to here. Again, I can run my tests and I'm not going to get any logging to that. So I'm actually going to write just a quick test that basically is not really even a test, but it's going to be it's going to run the elevator so that I can show you that it's working. This is not something that I would really ever have in my code. But if this was part of a larger code base, and it had actual functionality elsewhere in the code base that was calling the elevator function, this should work. Did I spell that wrong? Oh yeah, I have to add that. Okay. So if I just run this, oh, let's clean everything up just to make sure. Gonna get rid of those two logs. So I'm just going to run this, which is going to just instantiate the elevator. It's really not going to do anything else. But you'll notice that it prints out that the highlighting was initialized. That's fine. We have no log file locally here. Let's go back and look here. Maybe it takes a few minutes. We'll come back and take a look at that. We should have these logs appearing here now as they move through. Make sure we log to highlight, right? We're calling that with our public call. That should be enough to instantiate. I can actually call and maybe get a few other things. Let's call elevator.move and tell it to go to the 5th floor and run that again. Anything? This is, there we go. See, this is why I love live coding. So it looks like it's maybe about 30 seconds behind, maybe a minute behind. We should start seeing those roll in now as we, but we are logging to the cloud at this point. There we go. There's 4 new ones. All right, moving to 4. There we go. So at this point now we have actually pulled out and are using the, we're using the log to highlight here within our elevator, and we're not using it in the other 2 places, which is the joke for the ride service and the rider interface service. We're still using the log to file in those. This is one of those things that now I can push this out to the web and or to production and start using it right away. This I've separated my code that I wish to change. I introduced that interface, and I made the changes that were necessary just to do it enough for the elevator class. And let's go back. I think that should be it. Yeah, let's go back here. Right. So again, when we talk about the Strangler fig pattern, the benefits are that it's incremental. You saw that I was able to make the small changes or the changes in the elevator, but I didn't have to do it everywhere. It was controlled. I was able to make that small change and know exactly what I was doing without changing actually the functionality of the elevator class itself. There was really zero downtime in terms of if this was running in production and running in a much larger context. It was very low risk. It was testable. Maybe we'll go back and add a test or 2 for the logger. Again, do we need to test that functionality? Maybe, maybe not. It's really easy to release. And when you want to apply it, you pin that functionality using those pinning tests. You separate and isolate that code. You can extract it to a method, or you can apply an interface. You can use the dependency inversion principle to isolate that code. You implement those changes, and then you remove the dead code and repeat as necessary. So that's what I got. I'd love to take questions or comments and hear what you have, and let's discuss this a little more. Thank you.
Thank you very much, Paige, for this great session and this great exercise. Yes, indeed, we do have questions from the audience, and I do have a couple of questions as well. So I think we will start first with the questions from the audience, then we'll move to my questions. So the first question is from Danny. Danny is asking, what are the conditions where we need to add a pinning test if we already have good coverage for the existing functionality? That's a good question.
Yeah, and I think the answer is if you have good coverage, I don't think you need pinning tests. The idea behind pinning tests is for when you don't have coverage, you pin the current functionality of the legacy code, right? Because your legacy code has been running in production for a while. You know it works, but we want to make sure that by making these refactoring changes, we're not introducing a defect. So if you have really good coverage, there's no need to add pinning tests because the coverage should tell you if you introduce a defect.
Okay, thanks a lot, Paige, for that. We have another question from Muhammad Suelem. Will pinning tests stay in the code after completing code refactoring?
Yeah, I would. They're effectively, you're writing tests after the fact, and any tests are better than no tests. So if you are writing these pinning tests to ensure that the functionality doesn't change when you refactor, you might as well leave them in there, because eventually, or later, maybe not eventually, but later, if you make another change or someone else does, you want to know right away that that functionality changed. So yeah, it's not what I would suggest for how we should be writing tests, but when there are no tests existing, you need to write them to ensure that you don't introduce a defect later.
Yeah, this makes perfect sense. Okay, we have a couple of questions from Nariman. She's saying, I would like to know if we have legacy code, is there any way to make it at least modifiable, scalable, testable without using TDD? That's actually a question that I was going to ask. Is there any roadmap other than using the TDD? I think she meant methodology or practice to follow for making our code changes to have a cleaner, better code, or even make our code at least not being as legacy code. Okay, I have to hide that so that we would still be visible.
No.
But yeah, let's start with her question. And let me put mine. What do you want to say to people who would refactor legacy code without practicing TDD or some test-first approach, like TCR, characterization tests, or even approval tests?
As much as I am a proponent and I very much want to work writing test-driven or test-first development, because I think it's the most effective way to write quality code that I know right now. I know that also that's not always the way that it can be done. And especially if we're working in legacy code, I do think that you need to have tests, at least, again, going back to the pinning test, some sort of test that ensures that changes you're making do not introduce defects. So can we refactor legacy code without TDD or test first approach? Yes. Is it the most effective? No. Can we do it without tests? Well, yes, but the farther away you get from what I'm sort of talking about in terms of writing our tests or writing our tests first and that sort of thing, the higher the risk of introducing some sort of defect, the more work it is. If I refactor and add to legacy code, and there's no testing whatsoever, I may understand what I'm doing, but I can't guarantee that I haven't introduced a defect. And to guarantee that, then we have to go through a much larger process of retesting everything. You know, days or whatnot of regression tests, days of pin testing, like penetration testing, and all these sort of things that you need multiple people to do. And right, think of all the overhead that adds. If we can push that left and at least write pinning tests after the fact that sort of pin our functionality, we have at least a little more trust that the changes we're making and the refactoring we're doing hasn't introduced a defect. If we can write those pinning tests and then use test first development, TDD is a great one, right? That's the one I like, of using our tests as requirements. Then we can also ensure that the new code we're adding works because the test is passing, because all the tests are passing. Right. So, you know, the short answer is, can we do it without TDD and test first? Yeah. The longer answer is you can, but the trust and the trust in your code and the trust that we haven't introduced a defect grows as we get away from that.
Yeah, that's a great answer. Thank you very much for that, Paige. And I would like to add a couple of points. So, going back to what you were explaining at the beginning of your presentation, you've mentioned Michael Feather's definition of what legacy code is. So it's basically code without tests. So I think it's fair to say that what led to this code becoming legacy code was actually not writing the tests first in the first place. Okay. So if you're going to refactor still without writing tests, and of course, when we say tests, we're talking about test first approaches, there's no guarantee that this is going to be good code or better code. And in front of me here on the iPad, I have this text which I copy pasted from one of Industrial Logic's albums. And I think they quoted this from Michael Feather's Working Effectively with Legacy Code. They say code without tests is bad code. It doesn't matter how well it is written. It doesn't matter how pretty or object-oriented or well encapsulated it is. Okay. So they are really emphasizing on the fact that, look, without test-first approaches, it is still going to be legacy code, no matter how nice it is. And the funny thing is that it's fair to ask whether we can refactor legacy code without TDD. It's a good question. But the thing is, you can write production code without TDD. I mean, you know, your hand is going to still be writing the code. The IDE is not going to tell you, oh, sorry, no tests.
Right.
And no code. And it's still going to compile and everything. But this is not the right way to write code. Okay. So we recommend you work with test-first approaches when you're writing the code anyway, and definitely when you're refactoring the legacy code.
When I talk about test-driven development as, or the tests that we write as tests as as requirements in code format. You're actually writing those requirements that the code does this, the code does that. If there's an exception, the code does this. You're writing all of those into the test name and using the code within the test to guarantee that requirement. Right, and to drive the functionality to that requirement. And so I think if you think about it as that think about it as in that way, it often becomes a little bit more, how do I say, easy to form those ideas of what we're going to write first and what we're going to write in terms of why we write the test first. Because if I expect it to return, true, and I write a test that it should return true and it doesn't, then when I make it return true, I know that little part of the requirement is now passing. Right. So yeah, good stuff.
I remember reading in one of Kent Beck's book, I don't remember whether that was the XP books or the TDD book, but I remember Kent Beck saying that the permanent artifacts that remain in any software development project are the tests and the test code and the production code. Anything else, either it doesn't get updated that often, or basically is thrown to the trash. I mean, for people who are using Jira, and Jira is always a controversial topic, but once you move that user story to done in Jira, it simply disappears. You have to search for it. I mean, it doesn't disappear completely unless you delete it, but what remains is the test code and the production code. Those are the permanent artifacts that you keep in any projects. So if you want to still remember the behavior, or if you want to document your code, the best way to do so is to write tests, because these tests remain. And I think Mohammed asked a really good question. Do we keep the pinning tests? If they are of value, if they're documenting the behavior, of course we keep them, because anything else is lost or is not updated anymore.
I like that. I agree with that. And often when we look through our tests, we should be able to read them, the names, and understand what our code does. Here are the tests that we're testing. Oh, this is all the functionality that I can expect from this class or this unit that I'm testing. So yeah, I very much agree with that.
Yeah, it makes perfect sense. Okay, Peter has a question. So while TDD is immensely valuable for some organizations, it may be too great a hurdle. So that's a good point. Let's not conflate, I hope I'm pronouncing that correctly, having tests with writing them first. Yeah. So what's your take on that? Yeah.
Yeah. Thank you, Peter. I would appreciate, I always appreciate these comments from Peter. He's very good at this sort of comment. And I agree, right? We talk a lot about test first, test-driven development, because again, it's the best way that I've found to write software. And I don't want to sort of go down any other road. However, being a little pragmatic about it, I totally understand that there are places that don't understand this yet. And unfortunately, I don't understand why they have time to write the tests afterwards, but not before. It's the same time, and in fact, it's faster when you get good at it. But yes, if you write test-driven development, I think it's great. If you can't, for some reason, you don't have that forward-thinking company or organizational understanding, at least you have tests. That's good also. I'd rather see tests than no tests. I'd rather have test-driven development or test first than tests written afterwards. But again, on the scale, having something's better than having nothing. So yeah, we talk a lot about TDD. If it's something that you're unable to do, okay, then at least try and have some tests.
Yeah. I want to take this as a chance to read out parts of Clean Code by Bob Martin. That's actually in chapter 1, okay? And especially to the, people who are new to coding or, are not that experienced with coding, okay? Because there are people that are pro TDD and people that are against TDD. That's just the way it is with every practice in the industry. So I like the part in chapter 1 where Bob Martin says, that's fine, we can't claim final authority. On the other hand, the recommendations in this book are things that we have thought long and hard about. We have learned them through decades of experience and the repeated trial and error. So whether you agree or disagree, it would be a shame if you did not see and respect our point of view. Now, I know that Bob Martin sometimes can get a little bit, harsh and tough, strong language. But in the TDD workshops I teach, I like always to conclude the workshop with this basically part from the book. So yeah, while a lot of people would question TDD and have their doubts and like to discuss it, people wouldn't have recommended it unless it actually works and there is some value from it, because you are exerting effort writing tests for sure. I mean, it's more code, but you wouldn't be doing that unless it is of some value. Otherwise, why write more codes? Oh,
Right.
Okay. So yeah, just wanted to read this out. I think this was the best chance to do so. Thank you very much, Peter, for the question. Okay, if we don't have any more questions from the audience, I think I'll move to my question. So at the beginning of the coding exercise, you mentioned that some behavior did not have tests. Now, this is obviously something that you've prepared in advance, so you are well aware of it. But let's take the scenario, the common scenario where this is code that somebody handed over to me, okay, or some code that I haven't written. And I want to be able to know the test coverage, not the code coverage, the test coverage of my test suite. So are there any techniques you would recommend for developers to be able to find out what gaps are there in a test suite?
That's a good question. One of the things I've seen is around running with code coverage, right? Obviously, code coverage just gives you a number, but I believe in IntelliJ, you can actually run your code coverage and it will sort of give you a visualization of the lines that are not covered. So
Okay.
that's not a terrible way to do it, especially if you're really unsure and you want to ensure that you have those tests. You can look at those, and oftentimes it's something like you have an if-else statement, and the else is not covered, or you have a try catch and the catch is not covered, right? And you can know that right away, and then you can write that test that hopefully you can write that test that covers it. I kind of like that. It's probably the only way that I would really know for sure, because test coverage, the number is, I'm not a big fan of it as a measure, but I think it gives you an idea. The visualization in Visual Studio was actually more helpful.
Yeah, I fully agree with that. We were doing this workshop with Jeff Langer a few weeks ago, and it was basically teaching us how to use Gen AI and LLMs with legacy code and TDD. And we kind of were experimenting with, giving the artificial intelligence model the legacy code and the tests, and kind of telling it what is missing. Okay, so that it would augment the test suite. We got some interesting results, but I think the bottom line is human beings still need to make that effort and not rely on the AI or. But yeah, the code coverage idea. Actually, I was expecting you to recommend that. It's not a bad idea of course. Okay, but I think that people can also try out AI. Maybe you can,
Certainly.
get something from it, but to the grain of salt, as they say.
Yeah. And I think we were talking a little bit before we started here today about Llewellyn Falco and his the video that I showed. I believe it's the 0 to 100% coverage. You can probably search for it on YouTube. But actually, he uses that quite a bit in there. Now that when you mentioned it, it reminded me he uses that visualization, and so it's a good way to kind of see that how you could use that as well.
Yeah, actually, let me share the link. I think it will prove useful. So yeah, this is the link that Paige so kindly shared with me before the session. So yeah, please check out this session. I haven't personally watched it, but I will watch it as soon as possible. Okay, so yeah, I have one last question, and so I think some people who have seen the first test might ask this question, and this is usually something that people commonly misunderstand. So they've seen multiple assert statements, okay? And if someone has read the Bob Martin's clean code book, they would argue that Bob Martin says a single assert statement. So that's the recommended practice. So what is your take on that? Is that true? Should we have just one assert statement? Or is this something people commonly misunderstand?
So I think there's a misconception about that. And so let's go back to this idea of having the arrange, act, assert format. If you're familiar with that, we arrange all of our code for the test above. Then we have our action that we're calling to run, the functionality. And then we have our assert block, which for me is okay to have multiple assertions. What I really want to make sure is that I only have one action. And so that action happens during the act block and does one thing. And I think the confusing or the misconception comes in that sometimes we inline those actions into our assert. So in the assertion part, I could have multiple assertions as long as I'm not changing or creating functionality. So if the test is, say, get user, I call the get user in the act and I return it into a variable, which is the user. Then I can assert that the user first name is Paige and the user last name is Watson and the user city is Seattle, et cetera, et cetera. I can do multiple assertions on that. But what I shouldn't do is I shouldn't have assert that user first name is Paige, assert that user dot, add new dependent equals, two dependents, right? Because I'm doing another action there. And I think that's the where that kind of misconception of having multiple asserts comes in. If you are not changing anything, it is fine to have multiple assertions on the return value. Now you could say, well, okay, I create a user locally in my test, and I just have one assertion that equates them both. Okay, that's also fine. But there are times when you have multiple return values, or you want to see that multiple
Paige, are you still with us? I'm not sure if I'm the one who's having connection problems or have we lost Paige. Let me check that very quickly. Okay, I got a message from Paige, so Let me check out. Yeah, okay. So indeed we did lose Page. Um, okay, so maybe we'll wait for him for a couple of minutes, and if he's not back, I'm going to conclude the session. But I think I will be adding some more points to the answer he was providing to my last question. Um, so yeah, I remember in one of Bob Martin's videos, he said that it's okay to have multiple asserts, but as long as it's arrange, act, assert, and not arrange, act, assert, assert. Okay, so as long as you're asserting single piece of behavior, then multiple assert statements should be fine. Okay, but if you're performing a lot of actions and you're doing an assert after each action, then I think a better idea would be to split that into multiple tests so that you would still stick with arrange, act, assert, and not arrange, act, assert, act, assert, act, assert. Okay, so yeah, we will still wait for Page, but maybe in the meantime, let me announce the coming episode of the Tech Cafe podcast. So I think July is all dedicated to test-driven development, and on Tuesday, July 16th, Khalid and Nagar and I are going to be doing a session in Arabic titled TDD with test containers. And yeah, like today's session, this is going to be a session with a coding example. Okay. So don't miss this out. It's going to be a great session. And yeah, for our Arabic speaking audience, this is going to be in the Arabic language. Okay, so I would like to thank you all for attending today's session. I think Paige is still having connection problems. Please visit our website by simply scanning this QR or typing techcafe.com on your browser to check out our previous episodes and our different services. Again, I thank you a lot for attending today, and I would like to thank Paige Watson for being with us today. And I hope to see you again in a coming episode of the Tech Cafe podcast. Cheers.